Hey guys, welcome to another Swift deep dive. In this deep dive, we're going to look at the difference and the similarities between structs and classes, and when you should choose to use each. So previously we already saw that we could create a class like so, and by simply changing that class keyword, we can create a struct. But of course, structs are unable to inherit, so they don't have the part that classes have, where they're able to specify a superclass that they can inherit capabilities from. But there are a lot of similarities too. So in this class that we've created, where we're not inheriting from any superclass, it almost looks like a struct. And similar to structs, we're essentially creating a blueprint to be able to group together attributes and behavior into one component. And later on, we can use that blueprint to create an object from it. And we can use it to create as many as we want. So we could spawn, for example, a whole bunch of skeletons simply by tapping into that class blueprint or a struct blueprint. Now, similar to structs, we also have initializers in classes, so I could delete these default values and simply specify their data type, and these are both going to be integers, and then I can initialize it. Now, notice how if we have a struct, we get a free initializer. So we don't actually have to write the init method. But if we had a class, on the other hand, then we would get an error saying that class enemy has no initializers, so we have to provide the init ourselves. And I will do exactly that. So I'll provide an input called health, which has a data type of int, and then I have another one called attack strength, which is also an int. And once those inputs get passed in, I'm going to set the self.health, which of course refers to this current class's health property, which is this one. And I'm going to set it equal to the health that got passed in as the input. And I'll do the same with my attack strength property. And now when I go and initialize my skeletons, for example, let's say create skeleton 1, I have to provide those arguments, right? So if we go ahead and create an enemy and open a set of curly braces, you can see both the health and attack strength parameter expects a value so that I can initialize this skeleton object from my class and pass in the necessary values for my properties, which don't currently have a value. So let's say that the skeleton 1 has a health of 100, attack strength of 10. Now here comes the curious thing. If I go into my enemy class and I create another function, so let's call it take damage. So let's say that our enemy got hit. Well, then we can specify a damage amount. So let's call that amount, set it as an integer. And then inside the function, we're going to update the health property to deduct the amount of damage that it got dealt. So now when we call the take damage method, our enemy's health should be reduced by the amount that they got damaged by. And now if I want to create another skeleton, well, if I wanted another skeleton, say, let's skeleton 2, for example, I want it to be exactly the same as skeleton 1. So why don't I just set it to equal skeleton 1? So looking at this code, it would appear that skeleton 2 is a copy of skeleton 1. Let's delete the dragon code and investigate if this is indeed the case. Let's see what happens when skeleton 1 takes some damage. So skeleton 1 took some damage, so dot take damage, and let's say it got damaged by 10. Now, here's a question. If I was to print and get hold of my skeleton 2 object, and I wanted to access its health property, what do you think that should be? Remember that I copied skeleton 2 from skeleton 1 at the point where skeleton 1 was just initialized, so it had full health and it got an attack strength of 10. And then skeleton 1 took some damage, but skeleton 2 nothing happened to skeleton 2. It was just sitting around waiting to attack. So what do you think this line would print? And I want you to have a think about it before you run this code, because it's quite curious. All right, so if I run the code, you can see that what gets printed is actually 90. Why is it that skeleton 2, which didn't take any damage at all, why does it have a health of 90? Well, this is because classes are passed by reference. So here on this line, where I created a copy of skeleton 1, I haven't actually created a real copy. All I've done is I've created another reference to the same object. So this is basically a second reference to the same skeleton object that I initialized here. Had I wanted to create a whole new object, I would have to essentially copy this code and initialize a new enemy. For if I did this, you can see that skeleton 2 is completely unscathed when skeleton 1 takes damage. This is kind of dangerous though, because just by looking at this code, it doesn't look like as if that's what would happen. And this is why classes tend to be considered as more complex and therefore more error prone than structs. Because in the case of a class, this copying behavior is quite unintuitive, and we've now got two references to the same object. And if we manipulate that object from skeleton 1, say take some damage of 10, and we manipulate the object that we think is a separate object, we take some damage. Well, actually, what ends up happening at the end of the day is that both of these things are actually referring to the same thing. So if I go ahead and print my skeleton1.health and skeleton2.health here, you can see that they're both going to be the same, and they actually in total took a total of 30 damage, even though I thought I was manipulating separate objects. If we had instead created a struct instead of a class, well, firstly, in a struct, we're reminded when we actually mutate our struct. And that happens through this mutating keyword. Because this function will update a property of the struct, it alerts us to this fact already. And we won't be able to do this without making it mutating, because remember, structs are immutable. Now, when this function happens, the old struct gets destroyed and a new one with the updated value gets created. But when I make a copy of a struct, it really does make a whole new copy, and they're completely separate. So now if I try to run this code, it gives me another reminder that this struct is going to be changed. It says that cannot use mutating member on a mutable value. Skeleton 1 is a let constant. So this is a constant and this is a constant. So when we run that take damage, it has to destroy the old object and create a new one in its place. But because we have created a constant here with the let keyword, it is not able to do that. So we have to change this to vars. But now if I try to run my code, the first thing you'll notice is that I lose my capability of inheritance. So my dragon class has to be commented out because enemy is now a struct and it can no longer be a superclass or inherit from any class. But if we're still looking at our main.swift here and I run my code, you can see that skeleton 1's health went down to 80 because it took 10 damage on line 5 and line 8, and skeleton 2's health, the one that was printed second, actually only took 10 damage, so it still has a health of 90. So now you can see that our struct is being copied, and skeleton 2 is no longer a reference to the same object that was created in skeleton 1. It's in fact a completely separate copy, which means that when I do things to it, it doesn't affect my skeleton 1 or my previous copy. And so this makes it much simpler to understand the side effects and what might happen when I manipulate these objects. One of the biggest differences between structs and classes is that structs are passed around by value. So what that means is that if I had a photo and I wanted to give it to you, then I could make a copy of it and give you that copy. Now, classes, on the other hand, are passed by reference. So if I wanted to give you access to my photo, I would tell you where my photo is located. So I could give you the location of it on my computer. I could say it's under users/AngelaU/desktop/photo.jpg, and you'll find it there. Now, the problem occurs when lots of people need access to the same resource. Now, in the case of a struct, if lots of people have multiple copies of the same thing, well, if they destroy their copy of it, say you decided to draw whiskers onto my face in this lovely photo that I gave you, well, you've only just destroyed your own copy. Everybody else's copy is unaffected. Now, on the other hand, if lots of people had access to the same resource based on a reference, so they all knew where it was on my computer, and one of them accidentally deletes it, well, that's kind of it for all of us. We've all lost that resource now. So that's why Apple advises that you always default to creating a struct. So start by creating a struct whenever you need that blueprint to create new objects. But if you find that you need inheritance or you need to work with old Objective-C code, then you can simply turn your structure into a class. So that wraps up our deep dive on structures and classes. And to recap, here's a brief summary of some of the things that we talked about. Structures are immutable, meaning that every change that you make to the structure involves destroying the old copy and creating a new one. In addition, we saw how structures are passed by value. So it's passed around by the actual value that's held. Now, in comparison, classes are passed by reference, meaning that we can have more than one variable that points to the same object, and we're simply passing around the reference to that same object. In addition, classes have the ability to inherit from other classes. This means that we can use inheritance to add additional functionality to subclasses, as we saw with the components of Apple's UI kit. So if you'd like to learn more about structures versus classes, or read about each of those in more detail, I recommend heading over to this page in the Swift Programming Language Guide and taking a look at it. So I'll link to this page and you can get more of a background on structures and classes.